Everyone, thanks for joining us today. It's good to see you all here. It's just a quick one from me. I hope you find today's webinar insightful. After sponsoring this year's Space Talks events earlier in the year at the European Space Agency in Oxford, we've been exposed to some amazing projects within the industry. So we're really excited to introduce you to Jessie today, a leader and an expert in cybersecurity, which knits in perfectly with our expertise in custom software projects. So without further ado, I'll pass you over to Jessie to go ahead with it. Thank you.
Oh, thank you for that, both of you. And that's a really kind introduction as well. So I'm hoping that I'm hoping that you enjoy this webinar today. I hope that you find it interesting. As you can see, it's all about kind of resilience, security, and agility when you're kind of thinking about designing space systems. But it's really going to be a little bit of a kind of high level run through of this. These are the important principles, the important things to consider when kind of thinking about securing space. So just to start off, I'll just make my screen small. I don't know what you can see or what you can't see, but my name's Jessie Hamill-Stewart, as mentioned. I'm doing a PhD at the University of Bath and the University of Bristol, where I look at cybersecurity to space. I've looked at it kind of technically, looking at cyber attacks to satellite ground infrastructure, and then I've also looked at it more strategically, considering kind of international collaboration, but also cyber resilience and how that kind of varies across different states. It's really interesting research. And so when I'm not busy doing my PhD, I'm also have taken the role of program lead on the SciSpace Connected Capability Network, which is essentially one of 4 or 5 CCNs across the country. This one in particular looks at developing the UK's ecosystem in regards to securing space domain awareness in the UK, and it's funded by Satellite Applications Catapult. I'll be providing you with more information about this particular program and also how you can get involved in it towards the end of this webinar. So this is the structure of the presentation today. So I'm going to first talk to you about space infrastructure and what it really is, what I mean by it. I'll then talk to you a little bit about vulnerabilities and attacks that we've seen to space systems. And then the very important one, securing space. So what is required to secure space? What's currently the kind of industry standard to secure space? And then I'll talk to you a little bit about the SciSpace CCN and finally how you can contribute to this kind of space security ecosystem. And then there'll be time for questions at the end as well. So just to begin, again, hopefully you can see everything on the slide here. Mine's slightly blocked, but hopefully you can see it. So when I think about space infrastructure, I first often think about the services and the products that it provides. So we need space systems for many different things, many different purposes in the UK, but globally actually. So if you look to these pictures on the right-hand side, you look at the military communicating, aeroplanes landing safely, combine harvesters navigating themselves around the field accurately, vessels, finding the correct route across open oceans. These are all examples of infrastructure which relies on space services. So space, it can provide these kind of types of services. So there's imagery. One of those is perhaps allowing us to see what's really happening when a kind of disaster occurs, such as flooding. It can really help us to identify the breadth of the impact through images that are taken from space, transmitted back down to Earth. There's also communications, so that even when we make a phone call, sometimes that involves space infrastructure. When you listen to the radio, it's involving space infrastructure in some way. And when you are exclusively dependent on something like satellite broadband, such as the Starlink satellite broadband, you're very reliant on space infrastructure in order to provide you with that fundamental internet connection. And that applies to infrastructure like vessels in the open ocean. They increasingly, well, they use satellite signals to connect to the internet, but then also just generally kind of residential locations that are very rural and not close to ground infrastructure. Then the most important one is positioning, navigation, and timing. And this is a really important service that's provided by global navigation satellite systems. And this is what helps us to know where we're going. If we're maybe driving to somewhere new, it helps us navigate where we're going. But the timing also provides kind of this fundamental source of which allows the energy grid to sync, to remain in sync with itself. So we're really reliant on space infrastructure in many different ways. So that's one way of looking at it. Another way of looking at it is looking at the structure of it. And so you can see all of these segments. So we've got, this is more the kind of the architecture of space infrastructure, if you like. So we've got the space segment, and that segment is, that's the satellites up there in orbit, that are, the International Space Station. Everything that's up there in space is part of that space segment. Then there's also the user segment. And so signals are transmitted down from the space segment and back up again, actually, to the user segment. And this is where people are who are using those satellite signals, such as if you have Google Maps on your phone, you sit within the user segment. If you are operating a vessel or an aeroplane, then you sit within that user segment. And then there's also the ground segment. So the ground segment is probably the most important because this is where satellites signals are. This is where satellites are operated and monitored from. So this is a really important segment. It's not just those, but it's also the wider connected infrastructure, such as internet modems, which are reliant on kind of satellite broadband. It's all linked in, all controlled and operated and monitored from this area here, the ground segment. So I'm going to go into a little bit more detail now. I'm going to talk to you a little bit about the vulnerabilities that you'll find in each of these segments. I also did not mention there the link segment. That's all about these signals themselves, these lines that you can see going up and down from ground to space, from ground to space. And these signals are pretty important, of course. They're transmitting a lot of really important information, but they're also very vulnerable. Okay, so if we're looking at specific vulnerabilities, we might look at the space segment. So the space segment has quite perhaps an obvious or not obvious vulnerability, and that's the lack of easy physical access to it. So the space segment is quite an important segment. It's the infrastructure itself that we need in order to transmit those those signals and receive those services. But actually, by the time you've launched a satellite into space, it becomes very challenging to retrofit security measures and to update it while it's in orbit. Think about it going thousands of miles an hour, really fast, all around Earth. Imagine trying to align yourself to that. Not so easy. And we saw a good example of this when I don't know, usually if I'm in person, I'd ask for a show of hands. I can't see your hands, but you may have heard about this Boeing Starliner case recently, where some astronauts were supposed to be going up to space for around an 8-day mission, and then they ended up actually being stranded in space and staying there for many months, which was not ideal and not intended. And the reason for that was because there was an issue with the Boeing Starliner that they took up to space, and they were not able to resolve it themselves. So this really demonstrates that, and actually in the end, when they did make it back down to Earth, which you can see in this video clip here, they had to come in a different vessel. So this really demonstrates just how kind of inaccessible space can be. So then there's the user segment. So the vulnerabilities with the user segment kind of linked in overlap with the vulnerabilities of the link segment. And a lot of those are to do with the weak signals. So the signals here, these lines, they're very easily intercepted. You'll notice that if you go, if you're navigating yourself with Google Maps, like I do often, then you go inside a building, suddenly the signals are not accurate at all. They sort of put you at a street, 3 streets away. So apologies for that. So you can see that, yes, signals are really easily intercepted. Anybody can do this as well. Can purchase let me see if I can mute these. No, I can't, not easily. So anybody could easily purchase themselves a spoofing equipment or jamming equipment, and that enables them to disrupt signals. So essentially, not good. And you can see here in this very blurred picture, a vessel making its way towards I really apologize, the notifications, a vessel making its way to the open ocean, and it thinks it's going to the open ocean, but actually it has been spoofed. Its coordinates have been spoofed. So it thinks it's going towards the open ocean, but actually it has turned back on itself. It's going back towards land, where it was able to be seized by Iranian authorities. And this is just one example of how spoofing can be very impactful, even if it's just affecting one vessel at a time. So then there's also the ground segment. So this is the segment which shares the most vulnerabilities with other types of industrial control systems. So if you already work in the kind of cybersecurity area, you will be the most familiar with the vulnerabilities within the ground segment, because this has lots of the same issues, which I'll show on a slide very shortly, actually, that we see with the ground, such as legacy systems, such as complexity. So there is also that physical access to this layer. So there's increasingly we're seeing efforts to move things up to the cloud, which eliminates that physical access, but it comes with its own sets of vulnerabilities. But this is the most accessible layer, kind of segment, I would say. And so this is a concerning one. And I'll go into a bit more detail here. So this is a paper that I wrote with one of my supervisors, where we looked at satellite ground infrastructure and vulnerabilities and attacks. And we essentially aligned the attacks that we've seen against satellite ground infrastructure in the real world, in real life, to the MITRE ATT&CK framework, in order to kind of understand just how comparable attacks against space infrastructure are with attacks against other kind of terrestrial ground systems. And actually, as you can see here in the in the table on the right here, you can see that a lot of these tactics that we would be very familiar with in kind of common cybersecurity, if you like, you also see impacting the space system, such as initial access. Of course, they have to access it initially, but then also persistence. It was quite common for attackers to remain in space systems for many months. Even lateral movement, all of these things we are probably quite familiar with as terms in the cybersecurity community, and therefore it's and therefore you can see how there is beginning to be this crossover between cybersecurity for critical infrastructure, kind of which is terrestrial, which is ground-based, versus cybersecurity for critical infrastructure, which is in space. So we saw some of these kind of key concepts arise. So these are some of the, I was lucky enough to go to a seminar, an academic seminar in Dagstall earlier this year, where we kind of discussed and did a really deep dive actually into cybersecurity in space. It was a really cool seminar. It was amazing to just immerse myself into this exciting world. And what was nice about it was that we were able to kind of, this was the first exercise that we did. It's essentially, we did a big sort of mind map of kind of these are our questions, these are our issues that kind of are arising in regards to securing space systems. And again, you can see that some of these things are probably quite specific to space systems, like propulsion. Like, how cool is that? Solar system internet security. Some of these maybe are quite futuristic concepts, which are going to become issues when it comes to securing space in the future, because how do we, we're still mastering securing infrastructure on Earth, let alone infrastructure which exists entirely in space. So these are all really cool, interesting questions. But then you also see some of those similarities, the legacy systems, the complexity. Some of these things are comparable with terrestrial as well. So this was quite interesting, and you can see how there are lots of challenges when you think about securing space. The constellations, we're seeing things, cases of swarms of satellites. That's a lot of satellites, similar to kind of drone swarms. We're also seeing mega constellations. As technology develops, as technology progresses, it does pose more and more challenges to securing space. So I've painted you a nice picture here. I've given you a lot of kind of ideas of why we would be concerned about securing space. How do we actually do it? How do we actually do it? That's a good question. I think that when you're securing space infrastructure, it's really important to think about it in a very holistic way. And it's really important to think about all of those segments simultaneously that I've just mentioned. So it's all very well securing just a satellite, ensuring that it has maybe post-quantum cryptography, attached to it as you're launching it up into space. But if you're securing the link between the satellite and the ground, but you're not securing your ground sufficiently, then an attacker still has a way in. So it's really important when you're thinking about space infrastructure to consider all of the segments kind of simultaneously, and to consider how interconnected they are. So your phone is essentially vulnerable to a disruption that you might see in the space segment, or that you might see in the user segment, or what you're communicating with it or on it, what you're sending someone could be accessible because someone has intercepted the link segment. So there are lots of interdependencies between the different segments. And so the first thing that I would consider is the importance of taking a very holistic approach. So I was lucky enough to write this report with a security consultant called Neil, and he and I thought that it was very important to really emphasize the importance of a holistic approach to securing space. I feel like I'm repeating myself here, but it's really important. So we looked at it in three ways. Firstly, we looked at kind of both cyber security, cyber and physical threats. So of course, if you think about space, it's a little bit different to how things kind of work down here on Earth. And so there are lots of environmental factors that you have to consider in space, which are a little bit different to Earth. So for example, I mean, yeah, gravity is one example, but you have to think about the geomagnetic storms, solar flares. There are lots of, even radiation. There are lots of physical factors in space which essentially make space infrastructure vulnerable, that could also potentially makes infrastructure vulnerable, but then could potentially also trigger maybe false positives if you had an intrusion detection system on your satellite, for example, or that could trigger a satellite into shutdown mode. So there are lots of factors that are physical, that are environmental, like Kessler syndrome. I'm not sure if anyone's heard of that, in which there's potential for satellites to start knocking together, and then two satellites have a collision that creates debris, and then the debris impacts another satellite nearby, and another. So there are lots of concepts in space which you don't necessarily think about on Earth because they are not such a concern. So it's really important to think about both physical and cyber threats. But you can't just think about physical and cyber threats. You also have to think about all of those segments, as I've just mentioned, as I've reinstated. And it's really important also to think about the entire life cycle of the space system. This is especially important when it comes to space, because by the time a satellite has been designed, manufactured, looking all along this, and then launched, 15 years, maybe more, could have passed. So it's really important to have a lot of to be very forward thinking when considering how to secure space, and very forward thinking in terms of how to how to anticipate future threats and do something about them. So I would say that it's very important to consider from the design through to the manufacture, launch operations and applications. I'm not going to spoil this whole report for you. You'll be very welcome to look this up after the webinar. But essentially in the report, we look at attacks that have happened at each of these points. We look at how these points are vulnerable, and this might be something that might be interesting for you as further reading. In particular, the launch is quite interesting. So you may or may not know that space systems, that it's okay. There's been a lot of emphasis recently on sovereign capability, but actually, when you look at the launch ability, the ability for a state to launch a satellite or launch a rocket, launch a satellite into space, launch abilities are not entirely global, and so that means that often launch facilities tend to be shared. And so when they are shared, that means that you're not getting that kind of security by obscurity anymore, because more and more people are understanding how that same infrastructure at that launch facility is working. And therefore there is the possibility of understanding how therefore they could insert some kind of malware or interrupt them some other way. And so it's quite a vulnerable point actually when we have let's say a rocket ready to launch at a launch site that has just been used last week by another company, by another organization. There is that potential for the networks, the payloads to be impacted that are on the rocket versus those on the launch. So all of these different areas, they're always really fascinating, and there's a whole load of vulnerabilities that come into each of these areas. So it's really important to consider all of them when you're thinking about securing space. Okay, I've spent long enough on this slide. So there are also regulations. So if you're not willing to devise your own way of securing space systems, there are ways that you're legally obliged to secure them, especially if you want contracts with the military or with the government. So in the UK, I'm sure if again, I'm really making a big assumption here that you operate in the cyber world. If you do, then you might know about the NCSC Cyber Essentials, and this is actually, it's very good in providing kind of very basic baseline of cybersecurity, and this is used for companies that are contracted to government and military to ensure that there is security of space systems. But of course, it's not very specific to space. So in the UK, we also have the Civil Aviation Authority, which certifies components before they go up to space. And they work with companies to ensure that they are adhering to certain levels of security, which again helps to improve the security baseline, something that people are obliged to do before their components get sent up into space. And then there's guidance for communications providers provided by Ofcom as well, which is more focused on the ground side and securing those communications on the ground side of space. There are also a whole load of international standards. These are just two which are being developed. So one of them is the IEEE Space System Cybersecurity Working Group Standard. It was P3349. I think it's got a different number now. But this standard essentially looks at providing guidance by looking at each of these segments that I mentioned before, the user segment, space segment, link, ground, and looking at each component and each subcomponent within these segments in order to understand what is required for each of those subcomponents to that small level to secure a space infrastructure as a whole. So this is a really interesting standard. It should be published towards the end of this year. But actually, there's also the CCSDS, which is another standard which is well established, which large organizations follow actually. Ironically, perhaps ironically for me, not for you, the standard which you follow may be driven by the technical clarity that you want your approach. So this one combines systems engineering and cybersecurity, for example, or it might be geopolitical as well. And actually, international standards are very much more political than you would maybe think, even when it comes to securing something really important like space infrastructure. So that's regulations, the way in which you're kind of strongly encouraged to secure your space systems if not already. And then I wanted to also mention research as a separate kind of area. Oh, maybe because I'm doing a PhD, but also because it's a really important time to be researching the cybersecurity for space systems. And one of the reasons for that is because we are it's just fascinating that at the moment the academic area of securing space is expanding in a similar way to kind of the industry realization of the need for securing space. And so I don't know if it always happens like this. Usually academia is a little bit further behind, maybe. That's an assumption that has been made in the past. But at the moment, all of this research that's being conducted, even that which you can see on the screen now, is state of the art. And it makes it a really interesting area to be researching, a really interesting time to be researching it. So essentially when you're doing academic research now, you're contributing to what people need. And one of the reasons for that is because space has only really commercialized in the last kind of 15, 20 years or so. There have always been private companies kind of operating in the space in the space sector, but it's only recently that those companies have been kind of that the number of companies has really exploded, and so space, I would say, has never been so accessible right now, which means that it is new and securing it is new to a lot of people. Makes it an interesting time to be researching it. So if we're thinking about the future a little bit, there is a lot of new technology that's being proposed or even already in action. You can see I brought these new slides, new deck, but some of these stories are old. So these stories are from 2024. So these things are in action now. We're seeing AI and autonomy being used increasingly in space systems for many different tasks. It's actually been used for many decades, but again, with the development of the AI industry as well, we're seeing a lot more use of it, a lot more kind of experimentation and consideration of how it can be used. We're also seeing proliferation of the direct-to-device concept. I don't know if you've probably got 5G on your phone, but maybe not 6G just yet. When we're talking about 6G, we're talking about phones which can receive really super fast signals directly from a satellite. So it goes from the satellite to the phone, rather than from the satellite to the ground kind of infrastructure and then to your phone. And of course, this provides benefits for the consumer, but it also introduces new vulnerabilities because it makes satellites more accessible from the user side, which is it's very interesting to think about potential attacks that could happen in that area. So I hope that I'm not done yet, but I hope that so far I conveyed to you the importance of, or rather the crossover between space infrastructure and cyber. Because I think that when we're looking to the future and the future of securing space, it's really important that people in other domains, in other industries, realize how important their skills are to the space industry. And that is particularly the case of cybersecurity. Because cybersecurity, as I've mentioned a few times in this webinar, a lot of the skills that you need to be in that industry also apply to the space industry, but are not yet being applied in full, I would say, because space is often treated as special and a little bit different, and it is. It has its unique attributes, but it does also share a lot of those same common vulnerabilities that we have well established mitigations for in critical systems. So that's that. So I wanted to provide a couple of slides towards the end. Firstly, I'm going to talk to you about how you can contribute to the space sector, how you can contribute to this kind of growing field, because it's a really cool field, and I'm sure you're very motivated by now. So one of the things that you can do is you can come to conferences. So you've just missed one in Paris, unfortunately, which was SciSat, but it does take place in Asia as well, and also in the US. So there are some which are dedicated to cyber and space in the US, but there are also some in Europe as well. The ones for SciSat, the slides and presentations will be soon available, actually, so you'll be able to watch back on that one. There's also other ones in the UK, so the Defence in Space Conference, which will take place in October. This one is a nice one to attend because it is free to attend, so you could just go as a spectator and just learn a little bit about the space industry. And this is, I always think it's really cool to go to conferences, especially when you're trying to learn about a new sector, because it's only then that you realize just how friendly the industry is. So the space industry is exceptionally friendly. When I've go to conferences, I always learn a lot from people. I can just talk to people who are involved in satellite communications, for example, and I can learn a lot from them. So it's really valuable just going to these conferences. There's also globalmilsat.com, so they'll all have different kind of entry points, entry fees and things. You can also kind of speak to experts. It's really cool. I think that it's much easier to approach someone in person when you're at a conference to ask questions, rather than send them an email or a message, or there's nothing obviously stopping you from doing that. But I think that speaking to experts on the matter, again, I think a lot of people in the space industry, especially space and cyber, realize the importance of securing space, and therefore happy to expand it. And then conduct research if you want to, but also just share notes, share your expertise, share your knowledge with other people. If you're not from space, share your knowledge with people in the space industry. If you are from space, share knowledge in that way too. Okay, I'm going to come to my last slide, my penultimate slide. So I wanted to talk to you about the SciSpace Connected Capability Network, because this is a really nice way in which you can share notes. As mentioned, it's one of 3 or 4 programs which are funded by Satellite Applications Catapult in the UK. They are essentially 2-year programs, and the whole point of them is to facilitate cooperation and collaboration between people in different sectors who wouldn't usually get the opportunity to chat, to speak. We've had a really nice time of it so far. We started back in September last year, starting off with a working group where we convened government, academia, primes, SMEs, in order to kind of discuss what is space domain awareness, what is it in the UK, and what is therefore the importance of securing it. What we devised was an idea that space domain awareness is really important because it helps us identify what's happening in space, what potential disruptions could occur, what potential collisions are happening. But it's also a lot more than that. It's also the whole kind of ground process of data being processed and analyzed, and the source of it disseminated. So what we're hoping to do with this program, the whole reason it was really created, was to be able to advise government on the most important areas for securing space domain awareness. Because at the moment, space and cyber are 2 quite are two industries which are rather siloed from one another, and it's really important to bring them together in order to really understand what the capabilities are in the UK to secure space and essentially create justifications for further funding in the area. So what we've been doing so far is we convened the working group, as I mentioned. You can see that in the bottom right there. That's a nice group of people where we were talking about kind of what space domain awareness is, what is required to secure it. And from that point on, we've been proceeding to do some essentially a UK-wide space domain awareness and cybersecurity capability mapping exercise. So on the screen here, you can see at the top there is an expression of interest. So if you want to take part in that exercise, you'd like to learn more, if you'd like to simply just get to know what's happening in your region, then that's a good workshop to attend. We're going around to different regions of the UK. So we've been to Manchester already for the Northwest. We're also going to Newcastle in the Northeast. We're going to Edinburgh in Scotland. We're going to Belfast in Northern Ireland. We're going to different regions, coming down to Cheltenham and London as well, just to understand what is happening in that region in terms of cybersecurity and also space domain awareness. You don't have to be a space expert to come. In fact, if you come with just an open mind, then that's wonderful, because you will no doubt learn something and you'll be able to contribute to the discussions. And if you'd rather not come to those, but you want to learn more about the SciSpace CCN, feel free to register to receive updates down there as well. It's a really cool program. It's incredibly collaborative. We work with lots of space clusters and cyber clusters across the UK, and as well as the Catapult themselves and others. And it's a really nice program. So that brings me to the end of these slides. So I thank you very much for listening to me babble on about space and cyber, my favourite subject. I hope that it's been interesting for you, and I welcome any questions that might come this way. Thank you for your time and your attention today.
Thank you very much, Jessie. If anyone has any questions, feel free to ask now. If not, I will go ahead with mine. Okay, then, well, I've got a question, Jessie. I just wanted to know what you kind of predict when it comes to the space sector in the next month, year. I mean, you talked a bit about 6G. I'd love to hear what you kind of expect to see.
I think that more and more kind of new technology will be brought into space as more kind of experiments are conducted to kind of see what is possible in space. Because each time we attach something like artificial intelligence in some way to a satellite, we make it more clever. And then there are more capabilities in orbit, which is quite cool. And one of the things that emerged, as mentioned, was the solar system internet. But I think that we're going to see more of a, it's speculation really, but I think we could see more of a focus on kind of developing infrastructure in space in order to allow for more activities in space. So you may know that the moon is like a launch pad for Mars. So if we can develop more infrastructure on the moon, then that allows more exploration further into space as well. And so one of those is orbital data centers, but also solar power. These are all things which can then be, you know, come back to the UK. These are all things which are kind of modern. Well, they're modern right now, but they're under development. And actually, it's amazing to see how quickly things are developing. When it comes to private and public actors, I think that we will see a continuation of the commercialization of space, but that is kind of interestingly contradicted with a grow in kind of more of an emphasis on developing sovereign capability, so that if you are no longer friends with someone, you can still have access to space, and you don't lose your access to a launch pad, for example.
Amazing, thank you.
I have a question. If I was a bit late off the mark getting my my camera and microphone off mute. Hi Jessie, good to see you.
Hi.
I was just wondering how, because you touched on the subject of you know, space being thought of as a bit of a you know, slightly different to anywhere else, right? And I think we've seen this a bit with products in general in terms of cybersecurity. So I was just wondering how much things like the European Cyber Resilience Act is being implemented in space systems, because there is a tendency in a lot of industries to start reinventing the wheel when there's actually already a lot of practical advice there. So that was my question really. Is it being tied up, or is space sort of going off on its own thing?
Yeah, thanks for that question. That's interesting. I think unfortunately we are seeing more regulations appearing rather than less. Each it's not even at the larger kind of regional organization level. It's also the individual states. So at SciSat, I where I was there earlier in the month, I heard about French regulations which were revealed, which were specifically for securing space infrastructure, I think in orbit, so really specific. And then there were also German ones, which guidelines which have been revealed recently as well. And it does create a little bit of an issue when they are all slightly different to each other and not necessarily, well aligned. I think it makes it harder to operate in the space sector as a whole, because space systems are so incredibly globally distributed. You wouldn't possibly be able to kind of have your whole satellite life cycle exist within one one border if you think about those individual components needed for creating that satellite. And so you have to consider all of these regulations within the country that bit is being developed. So in fact, in Paris, we had this panel about regulations, the jungle of space regulations we were talking about. And the conclusion was really that where new regulations are being developed, so there was a question from Australia, for example, who are still developing their cyber and space regulations. We just sort of said, try and make them as compatible with an international standard as possible, because it does make collaboration easier.
Okay, thank you. Yeah, that sounds good, and I absolutely agree with you. And I think it's because you mentioned COTS devices and things like that makes it quite difficult for especially smaller companies to even get involved, right? And the first thing they meet is a barrage of a zillion regulations to comply with, which are, as you say, all basically the same but slightly different. So you still have to go through all of the certification processes, even though you're really certifying essentially the same thing. So yeah, interesting to hear that, and probably not something that's going to get resolved anytime soon. But it'd be great if they could be more aligned, as you say.
It's the geopolitics that really gets in the way, I think. It makes it challenging because certain states, certain individuals, companies, organizations will want to align to politically favorable guidelines, that have come from a politically favorable region or country. And so actually the politics plays a really interestingly large role in kind of dividing um, which regulations you can follow, and therefore create the creation of more regulations. And then you think about technology that's being integrated into space, like AI. I know I've mentioned it a couple of times or not so much as a buzzword, but as something that's becoming very realistic in space. They have their own set of regulations, so it does make it a little bit challenging. But I know that there are efforts underway to create kind of some global principles which can be followed, which are going to be global in nature and drawing upon a lot of regulations that already exist, which hopefully can be followed in a more global way. More to come on that later this year, I think.
Yeah, thank you. Thanks.
Amazing. Any more questions before we end the webinar? Don't think so. Well, thank you very much, Jessie, for your time today. That was an amazing presentation. Really appreciate it. And if anyone has any questions after the webinar, just send them my way and I'll send them over to you, Jessie.
I appreciate that. Thank you for the opportunity to talk about it.
Thank you.